Welcome everyone to the remote storage and large data set breakouts. We did, I believe, send everyone out who had signed up for the meeting the agenda. So I won't go into detail over it, but basically we've split up into just about a little over the first half. We'll be going through some presentations. I'll let each person introduce themselves when they do their own presentation. And the end of the last aspect of the presentation is we did recruit a couple members of the community to give a couple little quick talks about things they've been working on. The second half, we're going to have some discussion. And so we have three main topics that we thought could be interesting for discussion, but we're also open to basically any discussion, general discussion. So we'll try to do a little bit on each of the three subjects and then open it up and see, what you guys want to talk about. And then you've seen this slide already in other presentations, but the general Zoom etiquette, keep muted when you talk. If you're willing to, turn on your video so people can see you as you're talking. And we are recording this breakout session, so be aware that anything you say is recorded and will be public. Okay, so I'm going to start with an introduction and an overview. I'm Gustavo Durand. For those who don't know me, I'm the tech lead and architect of the Dataverse Project. And at the community meetings, you'll also know me as the one who always walks around and tries to recruit people for the Dataverse Cup. Sadly, we couldn't have it this year with the remoteness, but we definitely look forward to having a very exciting one next year. Generally, when I give talks, my first several slides are all introducing Dataverse and some of the features and things like that. Clearly, for this group, I do not need to do that. But I have kept one slide from my usual introduction, which is the Dataverse technology slide. And the reasons I did this is, one, is this is the first time that I'm actually presenting since we've confirmed that the next release would be Dataverse 5 and that we have moved to Payara 5. So you'll notice that instead of the glassfish logo, we have now this great looking Payara fish, and Java EE 7 has now been moved up to Java EE 8. But the reason I think it's particularly relevant to this breakout group is because we are talking about lots of different technical solutions related to remote storage and large data sets. So I think it is important to realize what the underlying technology that we're using, because all the decisions we make are affected by the technology. Everything we do for anything, but including this remote storage and large data sets, includes the UI. So we care about the presentation with using prime faces and our APIs. And then of course, a lot of what we're talking about here is storage. So the fact that we have local file system storage, we can store on Swifts, you can store on S3 is also very relevant to the things we'll be talking about. That said, let's move into the core of our breakout, which is the first part of it is remote storage. And so just so we're all on the same page, let's talk about what remote storage means. Basically, as with any data file, the metadata for the file is located on Dataverse. And the reason this is nice is because then you still have a full advantage of all the Dataverse features. You're still going to get persistent identifiers minted. You're still going to get the ability to create different versions of data sets. You're going to have access to the dynamic metadata of Dataverse. But what's different from the regular files, the way we've done files in the past, is that the location of the file is actually going to be a remote location for the file. And I'm going to talk a little bit about this in a second, because when I talk about remote storage in this context, more precisely what I should be which we should probably be calling it, is remotely managed storage. Because as you know, Harvard Dataverse and many of the installations do actually use remote storage. They store their files on S3, and S3 is not located at your institution itself. But in this case, even though it's stored remotely there, we still consider it local storage because all the management of the storage, all the access control is still controlled by Dataverse. Where we're talking about remote storage in this case, we're actually talking about where these access controls are managed by the remote location itself. And so that's the key. The data is located and managed remotely in this case. And it's very well could be just considered a black box to Dataverse. We just have to point the user to there and what happens, happens. But to make this more robust, ideally, these remotely managed locations would have some APIs available to gather some information. And so why do we care about remote storage? Well, the first is, and as you could probably tell from the name of this group, is large data. And so one thing I think it's important to point out is that while remote storage and large data are very connected, they don't necessarily mean they're exclusive to each other. So there are reasons for remote storage, which are not just large data, which you see on this slide, and I'll talk about in a minute. And similarly, when I talk about large data, you'll see that large data will not always need or want to be stored remotely. So we need to think of solutions for that. So in the remote storage case, again, the reason why we want to care about remote storage is it might take a long time to transfer the storage, the data. And if you already have somewhere to store it, then there's no reason necessarily to transfer it. It can help manage the costs for not just upload and download, but actually the storage itself. You may want to have it near the compute resources so that users don't have to re-download the data. And then also, there may be existing sponsored storage arrangements. For example, there's a group with us, I'm Dandy, I believe is the name, and they already have some arrangement with S3 Amazon to have free S3 storage. So they want to maintain their storage there while still being able to take advantage of the Dataverse features. Another reason why you care about remote storage is for sensitive data. Data needs to be stored in an encrypted way. You need to be able to block off access. And as we saw from the sensitive data meetings, with Crimson level data tag, the data might not even be online. So in that case, the remote storage is really remote, and it's actually an offline place. But again, it's still important to have the metadata available so people can be made aware of where the data is and learn where they need to go to figure out how to get access, what room they need to go to and what credentials they might need. And then there's also even proprietary reasons. One recent collaboration that IQSS has had with Facebook involves doing analysis of Facebook data to see if there's been any influence on the political elections. But as you can imagine, Facebook is very proprietary and wants to maintain their data and keep their data on site for them. And then the last reason that I've heard of is we've had some use case of legal requirements where a national funding agency, for example, might require any data that is their funding be stored in their actual nation. And so someone can't use Harvard Dataverse if the Harvard Dataverse is using S3 in the US. But if once we start allowing remote storage and the metadata is at Harvard, but we can still point to that remote storage location that's located in their country, then they would be able to use it. And so the key thing I want to cover in the overview is things that we should be considering when we're listening to these talks about these different solutions and when we're working on them. What's important for us as the core team that we think that we want to make sure we see in what we work on and what our collaborators work on, and what you guys think is important to consider. So for remote storage, like I alluded to earlier, it's really about the level of interaction with the Dataverse and the TRSA. The most straightforward remote storage is just Dataverse has the metadata and knows that when the user wants to access the data, we point them to a link similar to the external tools, but more about the storage side. And then whatever happens over on the other side is controlled by that remote storage. It's a black box as far as Dataverse cares. But to make it more robust, like I said, if the remote storage itself has some APIs, then Dataverse can actually ping the storage and learn more about the data. We can decide if the data is public or restricted. We can get some download metrics possibly. We can learn if there's a notary service and provide upfront some information to the user of what they're going to need to do to gain access. And there may be other levels of interaction besides these three that you guys might be aware of and can contribute to the conversation. The other thing that's important in remote storage is that they guarantee certain aspects of the storage. One thing that's always been important for Dataverse is to say, hey, if you have your data on Dataverse, the data will always be available. And so even when we're dealing with these remote storage locations, we can't just basically say, we're going to point you to Dropbox because someone could then go in and remove that file from their Dropbox storage, or they can change it. And we want to make sure that the data will always be available to those who have authorization and that data will never change. If they want to change it, they would actually replace the file and it would be pointing to a different file in their metadata. But the actual original file never changes and is always available as it was when it was cited. And so the main implementation effort that has been worked on for remote storage is being worked on by ODM. It's called the Trusted Remote Storage Agents, and John Crabtree is scheduled to talk a little bit later about it in more detail. But the one main thing I want to point out is I actually very much like the acronym because I think if we go in reverse order, it serves as a good summary of what I've said, which is basically this remote storage, it's an agent that Dataverse can communicate to via its APIs and can talk to Dataverse via its APIs. It's meant for storage, especially in cases of sensitive and big data. It's remote, and that's, in this case, remotely managed. Dataverse doesn't manage the access. And like I said, it's trusted. It's got these guarantees to make sure the data is there and available. Okay, so shifting, we're also going to have some presentations on large data sets and how we're trying to handle that and what people are working on for that. So this should hopefully go a little quicker because, yep.
It's almost 11:40.
Okay, got a couple slides, but these should go quicker because large data sets, everyone really knows what we're talking about. We're talking about data sets with large files. We do also want to consider data sets with large number of files, but most of the efforts have been focused on the former. And we're usually talking about files that are greater than 2 gigabytes because of that's web complications, but we're actually dealing with much larger scale and the order of magnitude of 1 terabyte or even more than that. And the reason we care about it is as we're working with more domains, we're working with bigger and bigger data. Biomedical has large data, astronomy has large data. Even in the social sciences, when we're dealing with Twitter data, we're starting to get these large data sets. And like I said, the standard way of transferring via UI isn't viable because it takes a long time, and no one wants to sit there and wait while it uploads and then have it fail right before it's finished and then have to start the whole process over again and have wasted an hour. And so the things that we want to make sure are important to consider when we're thinking about large data sets are that there's 3 separate concepts really: how it gets in, how it gets stored, and how it gets transferred out. And really, we should try to be thinking about these things independently. If I upload it a certain way, it doesn't really matter that I upload that way. I should be able to download it a different way if necessary, or access it a different way. In practice, though, there's always going to be some dependencies, as we've seen when we worked on the rsync code, for example. It's important that we make sure we maintain permission and authorization of these data sets and these files when we're locally managing the resources. But we do want to kind of minimize the app server workload. A lot of the work we've been doing with large data is to try to point directly to S3, and you'll see a little bit about that in a little bit. Cost management, about how it's being paid for, and not having to deal with all the costs of people uploading a lot of these large data if they have responsible for their costs. And then we do want to try to minimize these large downloads because, again, they take a long time. So the implementations, really quick, the rsync over SSH has been talked about in the past, but we did wrangle Pete to give a lightning talk, so we'll get a quick recap of that for a couple minutes. And then the other main talks that Megan and Jim and John are going to talk about are these other 3: the Globus transfer, the direct S3, and the configurable S3. So we'll be seeing those momentarily. So that's it for my slides. Now we'll go on to Megan, and she'll talk about the Globus transfer.
Okay, great. I will share my slides. Hopefully you can all see that okay. So I'll just introduce myself. My name is Megan Goodchild, and I'm the Research Data Management Systems Librarian at Queen's University and Scholars Portal. And so one of my big roles at Scholars Portal is working on our Dataverse team. And I'm really happy to be here today to talk to you about a recent project where we had an integration with Globus transfer. So as you may have seen in the opening video, Scholars Portal Dataverse is our research data repository. It's hosted at the University of Toronto, and now we have 55 Canadian institutions participating. And much of our development focus recently was on a national grant for RDM development from Canary. The aim was to develop reusable and scalable tools for Dataverse around 3 areas: authentication, data curation, and scalability and large file support. And we recently completed this 18-month project, and if you'd like to learn more about it, I invite you to check out this recent blog post that we posted, and we'll have the slides afterwards so you can have the link to that as well. So today I'll be talking about this 3rd area of the project around scalability and large file support. This was inspired by a user story, a very common user story actually. As a user, I want to upload files larger than 2.5 gigabytes to Dataverse. This is a really common request. So the main aims of this part of the project were to optimize the system architecture for scalable use. We wanted to be able to connect to existing Canadian storage environments. And we also wanted to improve the ability to handle large files in both upload and download contexts. So one of the deliverables was to connect to cloud storage, which we achieved by connecting to a test cluster of the Ontario Library Research Cloud, or OLRC, which I'll talk about in a moment. And the second main deliverable was to integrate with Globus as a large file transfer mechanism. So I'll talk about both today, but focusing on the latter. So the first deliverable was to connect Dataverse to cloud storage, and we used a test instance of the Ontario Library Research Cloud. This is a distributed cloud storage network. We have 5 nodes across Ontario. And the way we did this was actually by using Amazon S3 emulation on top of our OLRC cluster. So the way we did this was just by adapting the normal Dataverse S3 drivers. So we're actually using S3 as a storage target, but it's actually our OLRC underneath. We're really pleased with this design because it allows us to more easily scale the system, but we're also able to leverage that robust Canadian infrastructure for storing data, which is very important to our users. So for the large file support part, This is, we're drawing on Globus, which is a nonprofit project developed at the University of Chicago and Argonne National Laboratory. It's based on the needs of researchers, and it really provides a fast and reliable high performance service for secure data transfers. It allows you to transfer data between two locations that they call endpoints. So it's defined as a source endpoint and a destination endpoint. You can use the web browser UI called the Globus File Manager, or you can use command line tools as well. In our context, users would need to be able to use this by having a free Globus account and then also download the free Globus Connect software. And this runs in the background. The benefit is that it is able to handle really large scale data transfers, maintains security, uses encryption, and actually resumes automatically as well. So if there's a network failure or something like that, it just resumes really quickly. So if you'd like to learn more about Globus, there's a link there. So we did a proof of concept integration as part of this Canary project to use Globus Transfer as a large file transfer tool. We first got a trial license for a Globus Grid FTP server and then set up a managed endpoint at Scholars Portal. Some of the development work included making adjustments to the Dataverse UI so that could incorporate the transfer steps for uploading and downloading using Globus. We also used Globus's APIs, so that would allow Dataverse users to log in using Globus, then create a directory in the storage of Dataverse, and then obtain permissions to read and write for that directory. And then Dataverse would also need to redirect the users to this Globus Transfer UI with the dataset destination directory kind of already set up for them. If you'd like to check out the development, it's all open on GitHub and the link is there. I just wanted to mention that we did develop this with version 4.17 at this point. So I have a diagram here. It's kind of complicated to see, I'm sure, on your screens, but I'll also talk through just in plain English on the left that you can see too. So this is really just the workflow for how it works. So after a user would save a data set in Dataverse, they can click upload via Globus, and then they would be redirected to the Globus file manager in a separate browser window. The user's computer would again need to be running Globus Personal Connect in the background and then needs to be logged into the Globus account. So what happens then is a directory is created for the data set and the destination endpoint. So again, this is our S3 emulation, and the user is given edit access. And then when the user transfers the file from their source location, so a source endpoint, that could be their computer or a server or whatever, it uses Globus Personal Connect to transfer it to the destination endpoint in the directory that was created on our side. So the Globus server really facilitates this transfer using Dataverse S3 as the storage target again. So I'm going to do a little demo, but in the interest of time, I've just kind of recorded myself going through the steps, and I'll talk over that for you. So first step here is that the user would create a new data set. And hopefully we all know how to do that at this point. So we got test data set for Globus demo. You have to save it first, which then allows Dataverse to know that we're ready to look for the Globus option here. So it says before you need to start, you need a Globus account and Globus Personal Connect running. Click upload with Globus. This opens the new window. We're now looking at the Globus file transfer window. So the source endpoint's on the left, the destination's on the right. I'm just gonna press pause for a second. If I could go back. So the source endpoint's on the left, the destination's on the right. You can see it's pointing to our Dataverse test collection, and the directory is based on the DOI. So you search within your directories here. I'm just looking through my hard drive, so please no jokes about how poorly I've organized my files here. So I'm grabbing some test data. You can grab a whole folder full of directories or just several files. It will keep the directory structure intact. You start the transfer. And then what you can do is you'll be able to monitor the activity. If it's a really large file, you'll see kind of the progress as it chunks and moves it. You can see that it's started, the tasks and things like that. There's an event log as well. So you can see exactly how things are going. In this case, it's a really small transfer, so it's already completed at this point. So if you go back to the file manager now, you refresh, and you can see the files have now shown up in the destination endpoint there. We go back to the Dataverse side. We have, for a proof of concept, we needed a manual sort of acknowledgement to Dataverse that the transfer had finished. Obviously, in more this is just the proof of concept. So once we would develop this further, this would be a more automated process, of course. But you can see here the files have transferred, and it includes all of the file level metadata like checksums and things like that. You also see here that now that these files have been uploaded, there's now a new option to download via Globus, and that's exactly the same process, just in reverse. So a user would again need to have a Globus account, have Globus Personal Connect running, and then they would just move the files from Dataverse to their personal endpoint as well. Hopefully that wasn't too quick, but time is of the essence. Okay, so we did some testing about the performance, and we were really happy with the results. So you can see here for the testing, we tested directory size from 10 gigabytes to 100 gigabytes with a small number of files, and we also did it with a large number of files as well. And you can see for 100 gigabytes with about 30 files, it took under an hour. And then when you get up to 38,000 files, it took over 8 hours. But very robust, and we tested with losing the connection and things like that too. In terms of considerations for this integration, there are a lot of desirable features. It's very robust, as I mentioned. Globus is also currently being used by Canadian researchers, and it's also the tool used by our National Research Data Repository and Discovery Service called FURDR. So there are advantages there to using the same tool across platforms. We also found that Globus has it's better for cross-platform compatibility compared to other options that we investigated, since it is being done in the browser and you download a software that can be used on any platform. So we thought that was a very good feature. In terms of limitations, the Globus license for a managed endpoint can be quite expensive depending on the size of your institution. So this would need to be negotiated, and that's something to consider as well. One thing we found is that users can only be given access at a directory level in Globus. So we weren't able to have file level permissions. They don't seem to work appropriately. So we need to investigate this and develop that further. A few issues with the current interface as well. We need to internationalize it because we are a bilingual country. So that's really crucial for us. We need to be able to translate it into French. And we also found that the UI is quite complex, so it's difficult to navigate. There might be a steep learning curve for users as well, although it is quite, you could learn how to use it quite quickly. We also, as I mentioned, need to find a way for Dataverse to be able to sync and check when the files have been uploaded as well, so we don't need a manual button. So next steps, we are looking to do a tighter integration to work out these bugs. It's possible we might want to design our own specific UI for Dataverse rather than using the Globus Connect interface. We could leverage the Globus APIs and have a more streamlined workflow within the Dataverse context. So we've been in discussions with IQSS to get their support to see what we need to do next to develop it. We'd really like it to end up in the core code and not a fork, so that's difficult to maintain, of course. We're also investigating how we could incorporate this into our service at Scholars Portal, aiming for release maybe next year. So I just wanted to say a quick shout out to our team. Thanks so much to everybody on our team. It's a really collaborative effort, but especially to Victoria and Janet B. I invite you to email us if you have questions, if you'd like to ask questions today, please add them to the chat or save them later for the discussion. So I'll pass it now over to John Crabtree, who will be talking about TRSAs.
Thank you, Megan. Let's see if I can share the right screen here. Desktop 2.
I can see it.
Okay, can we see the right screen here?
Yes.
Is everyone seeing the full screen, not the presenter screen?
Yes.
Correct.
Yes, just the full
Okay,
screen.
good. Good, good, good. So, remote storage, big data, lots of things, lots of components here in lots of different interesting ways. I think the key to all of this in my mind is flexibility, because all of the things we've heard are what people need to do. And researchers need it, different communities need different things. So the idea is make things modular. And that's kind of an idea behind Impact, and Impact is the grant. We talked a little bit yesterday in the sensitive data section about Impact, but Impact funded some of the work on this trusted remote storage agent we're talking about. And the Impact team is a very diverse team from the folks here at UNC, as well as the folks over at Duke University as well in Rentsy. And we even had a pink team to review our security requirements as well. But the idea behind Impact was to decouple the data and the metadata to enable discovery. It's very difficult for many reasons, not only for sensitive reasons, but for large data reasons, to move data. Leaving data where the compute is really important. Leaving data behind firewalls is really important. So the whole idea was to decouple that idea of metadata and the data. Now, we know as Dataverse users that we rely on that metadata. The metadata is very, very, very important. So we need to be able to extract that metadata. And when Dataverse cannot access the data, that's very hard. So that was the idea behind the TRSA, to decouple that. We also wanted to maintain the autonomy of the data owners so they controlled access. Whoever is in charge of the data is responsible for that data, and they control the access, and they do the deposits, and they manage who can get in and out of that data. We also try to help people navigate the DUI options, and there's so many different data use agreements, and they're all individualized for each data set. And we want to help automate some of that compliance, and then we want to be able to make things repeatable. Now, I won't talk about all of that here. I really want to talk about the TRSA here, and here's it's a fairly complex diagram, but the major part here is that Dataverse is the discovery mechanism for this Impact system. Dataverse has to have all of the metadata. It has to have the study level data and the file level metadata within its tables in order for users to discover it, to make that determination whether they want to jump through the hoops to get it. But what we found over the years is that being able to allow researchers and users to see inside the data, to see those variables, see the variable labels, look at some general statistics, if they can look at those things, then they can make a good determination, yeah, I want this. Uh-oh, it's sensitive, or uh-oh, it's big, but I want it, and it's worth going through the hoops. If you don't share that information, the challenge actually becomes back on the repository, because in many cases, the researcher will see it, they'll say, ooh, I want it. They'll jump through all the hoops, spend all the time, take all your curators and your archivist time and your technical people's time moving the data, and then they'll get it, and they'll say, ugh, it's not exactly what I wanted. I don't need it. So now you've wasted everyone's time. So the idea is we can provide enough information that researchers can make good decisions on whether they need the data or can use the data. And then they'll go through the hoops it takes, whether it be big data or sensitive data. And then those different kind of hoops are Impact. You don't need all of the Impact pieces. Notary servers can help handle that. We have policy servers, we have compute environments, but the idea is that all that can be decoupled from the trusted remote storage agent. Trusted remote storage agent just sits on top of a file system. It extracts the metadata. It uses the Dataverse API to push the metadata over into Dataverse and make it discoverable. It can give Dataverse a link. Right now, in our use case, it's giving it a link to the notary service. So if you want access to that data that's sitting behind that trusted remote storage agent, you go through the notary service. But you also can send just a web link. If it's not secure data, we've actually got a prototype of it that you can, it'll just send another link and it'll carry you right back to it. And we'd love to think about how to expand this system beyond just the secure data. So the idea behind this thing is it makes the private data or the big data discoverable in Dataverse without having to move the data. it's owned by the data provider. So you don't give up that access. And that's a challenge. And many times they cannot give up. They have rules that say they cannot give it up. It basically collects, and harvest is a loaded word here because we know harvesting in Dataverse means something else. But it's very similar to harvesting in that it collects all that data and pushes. It's not pulled by Dataverse, but it collects it and is pushed, and it uses the Dataverse API, the deposit API for that. It's a fairly lightweight web GUI client that sits on top of the server. It allows you to do things like manage the profile. This profile, if you recall back from what Gustavo was talking about, the idea here is it has to be a trusted agent. This is not just anyone can run this. There has to be a link between a Dataverse and a trusted agent. And that profile handles all that information, and you can manage your Dataverse data and things like that. So you have a profile that has things like your API token, where your data is stored at locally so we can navigate back to it. If you're using notary service, what is the notary service? If you're using a safe server, we call it Presidio. That is actually the local gatekeeper that's managed locally. If you have those, you can edit and change all those there. You basically set up these different data sets. So I've set up a couple here, but basically the data sets are linked from Dataverse via the DOI and the URL back to the storage agent, and they maintain that link, and we have reporting that goes and browses in the direction to pull back to make sure everything that you pushed up there is still up there. It is a very simple process. It's similar to a regular ingest process. It can process quantitative data, and it does all the same routines that Dataverse does. It'll take those portable files. You can choose them, drag and drop them, upload those things. Once you have created this submission parameters, you publish that data set, and it pushes all of that metadata over into Dataverse. The policies that are defined locally by the data provider, and that notary service I talked about is what verifies if the policies are compliant. And then we have a guard in front of it. But if it's just big data and you don't need security in front of it, you don't need all of this. You can just provide a link, whether that link be back to a web service or potentially other types of linkages. So the idea was that we want to coordinate that file service in that central area. Again, for a large data, you may not need that, but it's very, very modular. So where we think that would be really important is that the TRSA should not only be used for sensitive data, but big data as well. And what we really need is more storage drivers. Right now, it's working on local UFS Unix storage. What we'd like to do is add storage drivers for Globus, iRods, S3, all of those things underneath it. So TRSA is familiar with all of those storage systems. And that way we can send Dataverse the link back to the direct link back to those storage systems. So in these cases where we want to calculate that and compile all of the metadata remotely, then we can send it back to Dataverse, and if the data is stored in one of these other types of remote stores, we can point to that. And that's the next direction we're going with this. And there's lots of projects ongoing that we'd love to coordinate with, because I think there's lots and lots of overlap here. And then maybe some of our tools that we use to extract metadata with can be used with some other tools as well. So I think there's lots of things that we can maybe work with Jim and the GDCC to start coordinating some of these projects where we can share knowledge and make things even better. It's a big team, as I said before, many different groups. There's a website that has, it's cyberimpact.us. It's got some really good blogs that go through all the architecture. Everything's open source out on GitHub. There's also a video that explains all the whole components all the way through if you'd like to, and always give us a call if you have anything. So other than that, there's some resources on the slides, and I'm sure they'll share the slides as well. So there's tons of resources in these slides, and everything's a federated login with it. So other than that, I'll stop sharing so we can go on to the next piece and answer some questions maybe.
All right, thank you, Jonathan. Should we move on to the next presentation, Gustavo?
Yes, I think Jim is next.
Okay. All right. Jim, are you ready?
Yes, I am. Can you hear and see?
Yes.
Okay. So I'm going to tell you sort of about a simple system by comparison to these, and then on a last slide, kind of discuss where some of the simplicity in here might help now that we have multiple examples of remote stores and TRSAs, whether we can start thinking about a redesign that would make maintaining those easier, making it easier to add more stores to them or develop new ones, which is a little more speculative. But to start at the beginning here, so Anna is going to tell you a little bit more about the Texas project that started supporting this. I'll just tell you sort of the mechanics of what kind of came out of there and where it's gone next. Prior to 4.2, Dataverse had a choice of stores you could put it on, but you could basically put it on one at a time, a file system or an S3 store, Swift object store. And because of the use cases, kind of like Gustavo was saying with being able to have stores managed by different stakeholders, or to have stores where one is for large data, other ones are, another one's for smaller data, maybe hosted at different places because of the different costs that you could get at those different places and so on, or different stakeholders behind them. And even, one that's available, sort of the first bullet there is just, if you ever started out on a file store and then wanted to switch over, your only choice in the past was to move all of that data into an S3 store. Now you could add an S3 store and say everything new goes into there, and I'll just leave my smaller collection of file stores where they were. So that was sort of a step one, was to get where you could set up multiple stores and use any of the file system S3 or Swift stores as before. And I think that's all I want to say there, other than some of the stuff here, basically with the multiple stores, some of the options that used to be sort of system-wide are now things that apply to a particular store. So whereas there used to be one S3 bucket for the entire system, now there's a bucket for each store that you set up, and so on. So one of the changes because of the multiple stores is some changes in the JVM options, and that's really the main thing that you needed to do if you wanted to adopt multiple stores and to upgrade. The thing that went on top of that then is basically allowing direct downloads from S3. So one of the things that's been around for a while, I don't know where it came in exactly, but when things are put into S3, the upload process was that it goes to the Dataverse server, gets sent to S3, but then there was an option that if you wanted to be able to download that, you'd make your request to Dataverse. Dataverse would check access control, and if you were allowed to get it, it would send back to your browser basically a redirect request that say, here, just take this URL and go get it directly from S3. And then all the bytes would go directly from S3 to your browser, not involving the Dataverse server. The upload is essentially the inverse of that. You ask Dataverse, I'd like to upload a file. It says, great, that's going to go to S3. Here's the URL. You can talk directly to Amazon or MinIO, whatever your S3 server is, and send the data up there directly. And then when you're done, you tell Dataverse, it's done. Please now register that file as part of the data set. Here's its title. Here's its MD5, all the metadata the data wants to handle. So in doing that, there was both an API extensions to be able to allow that from external tools, one of which is the DB uploader, but these APIs are available for things like PyDataverse and for your other tools and so on. And then through the UI as well. And one of the nice things, because of the thing I'll mention next, is that this was really easy to make it look like it's the normal upload. As far as the user's concerned, they're selecting files just like they do with the normal interface. That series of files is getting pulled and pushed up to the server, and you can see progress bars, and when you're done, you hit the save button at the bottom, and you didn't have to do anything else. So it really was turned out to be a nice way to integrate this. And the key piece of that is really this idea of a pre-signed URL. In these scenarios, Dataverse has a key to Amazon that allows it to do whatever it wants in the bucket, to put files, delete files, right? All the management functions. And the user has no account with Amazon S3, doesn't know anything about it. What happens is when you ask Dataverse if I can upload a file. Dataverse asks Amazon, says, here, I'm an authorized user as Dataverse. I would like a URL that's sort of one time only for a short time, just for this file, just for the person who has this URL. Let them upload it. Give me that URL, I'll hand it to the user. The user uses that. They can't delete the file after they put it up there. They can't get access to any other files, right? They really kind of, it's kind of like all the Google Docs stuff we're doing to get to the community notes right now, right? You don't have to have an account. You just have to have that URL, and that lets you in. So that kind of idea of the pre-signed URL is really the technical magic under the hood that makes it easy to make this look like a normal upload through Dataverse. The two things I put down at the bottom here is one of the things that we realized when we did this for Texas using a MinIO server, we were able to start getting 60 to plus gigabyte files going through directly. But the first time we tried it on Amazon, we realized that if you try and send your file as one stream, Amazon stops you at 5 gigabytes, which is a smart thing to do, but was a problem in the way. What you can do to get around that is kind of do more what Globus FTP does, is to break the file into parts and send all the file parts. So part of the development that's gone on after we handed this over from Texas is we've been adding the ability to break the file into multiple parts, even send those parts up in parallel so you can get some of the performance advantages. And then when it's all done, same thing. But the idea is, again, that's going to look to the user like it's the same thing as before, because all of that stuff, the splitting into parts, checking the multiple parts are getting there, and assembling the whole thing at the end is all done kind of by the software behind the scenes. The user just sees the file going up. The other thing that was limited and has become less limited in this is that, if you think about the idea of when the file goes to Dataverse, it does some nice magical things like looking at the file and even some of its content to see if it can recognize the MIME type. So if the user sent up something that the extension doesn't match, if you look inside and see the first few bytes say GIF87, it's a GIF image right off the bat. So there's a lot of that kind of magic. There's the ingest magic of taking tabular files to tabular. There's unzipping and so on. And some of those things don't necessarily make sense for large files. You may not want to change into a tabular file a terabyte spreadsheet just because it's a spreadsheet. So we added some things to allow you to do some of those processes on smaller files and set a limit that if it's going direct, we'll still pull the stuff over to Dataverse to let you do some ingest up to 2 megabytes, 10 megabytes, whatever you want to set it as, and bigger files will just let go through without some of these things turning on. And the one piece that's really not there yet is having Dataverse check the MIME type, because the current implementation basically would pull the entire file over to Dataverse before we check the MIME type, which we didn't want to do. So, but that's on its way. All right, so that's basically what's there. And again, if you turn this on and things are configured, it should just go. The users don't see any difference. The one thing I wanted to point out is that going back to Gustavo's slides again, that one of the reasons this was relatively simple to create is because Dataverse still has access control of this file. Nothing except the storage is happening over at Amazon. And that makes a nice split that Amazon doesn't know anything about Dataverse's access control model, doesn't know that you have to accept terms and conditions or that some files are restricted or anything else. Dataverse handles all that, and just when it's made the decision, it hands off through this pre-signed URL. And the interesting thing would be the question of whether we can actually use that type of thing in other stores, all right? Or for example, if Globus were to implement a pre-signed URL that could be generally useful. It wouldn't have to be a Dataverse specific thing, and yet it would allow simplifying what the Globus FTP stuff. If TRSA could, now that we've got multiple stores, it might be able to find a way to do the manipulations it does with Dataverse more simply if we use this kind of model, or if we make a few further changes to the store model. Particularly now that we've got multiple stores, you could have your normal S3 store, and you could have one that's tied to the TRSA or something like that. So I'm a little bit babbling of kind of thinking out loud about new ideas to do things, but I think that's one of the things that we could and should be doing at this point, is we've got enough examples to start asking, you know, would it be less programming work if these things could all be used as stores? Are there changes to the store interface we could do to make it simpler to build these type of things? And again, to me, the pre-signed URL is a key piece of this that helps to decouple the two things on either side. All right, so with that, I'll hand things back. Thanks.
Excellent, thank you very much. And I think I'm the last presenter before our lightning talks. So let me share my screen. All right. Can you all see that?
Yep, we see the
Okay,
presentation.
excellent. Thank you very much. All right, hi everyone. My name is Anna Dabrowski. I work in the Data Management and Collections Group at the Texas Advanced Computing Center. And so today I'm presenting on a collaboration with Jessica Trologan at the UT Austin Libraries and Courtney Muma with the Texas Digital Library. So our work is part of what we're calling the Dolce Initiative, which stands for the Digital Object Lifecycle Initiative. And this is very much a name from the TAC perspective. So one of my colleagues came up with this as a way to generally refer to the computing center working on projects with the libraries. And in this presentation, I wanted to follow up on Jim's talk. And the idea is to put his development work in context for the Texas Data Repository and give our pilot project implementation, or give an idea of our pilot project implementation with multiple data stores. So our project was born from a desire to align interests across two quite different organizations at UT Austin. Both TAC, the Texas Advanced Computing Center, and the UT Libraries have heard from researchers expressing a need to be able to easily publish large data sets. And on the TAC side, we primarily focused on high performance computing infrastructure for research. So we serve a diverse community of researchers across the US and internationally. We usually support computationally intensive workflows to process data on our machines, but we also do provide storage systems for researchers to archive their data. In my group, in the Data Management and Collections group, we support larger projects that build out data collections, but these usually have custom data models and software stacks, and data publication might be one objective of many for these kinds of projects. And that process is usually grant funded, it's more intensive, it's for larger projects. And most notably, TAC hasn't really functioned as a stewarding organization. Rather, we provide that
Jason,
support.
sorry, this is John Crabtree.
Yeah. Jonathan, I think, can you mute? Okay, I'll keep going. So notably, TAC hasn't functioned as a stewarding organization. So we provide the support, but the research community is responsible for determining the management, the curation, and the maintenance of their data over time. So from our side, the interest in being able to easily publish large data sets is being able to create some kind of a pipeline that would allow researchers to move from data processing and analysis at TAC to publication directly with the stewarding organization without necessarily needing to take on these larger software development projects with us. On the other hand, the UT Libraries mission is to provide services for the UT community of researchers, and these services include data management support. And so they manage the institutional data repository service, which allows UT researchers to publish data within the Texas Data Repository. So TDR itself, the Texas Data Repository, is a consortial data repository and it's built on the Dataverse software platform, and it's hosted by the Texas Digital Library for member institutions across Texas. The UT Austin libraries are one of those members, and the data that gets published by UT researchers in the TDR is treated as part of the library's stewarded collections. But the limitation that they face right now with the way that the TDR is implemented is that data files are restricted to 4 gigabytes in size and data sets to 10 gigabytes. So on the library side, the interest is in being able to support UT researchers with publishing these larger data sets within the existing Texas Data Repository system. So our pilot project has taken a first step towards aligning these interests in larger data publication. So UT researchers with larger data sets, they may or may not be TAC users, would be able to publish their data in the Texas Data Repository, those larger data sets. And so Jim described his development work that would allow the Dataverse software to manage the multiple data stores and improve the data ingest process with direct upload. And thanks to this, we're able to connect the TDR directly to TAC storage systems in addition to the existing Amazon S3 store. And so what this gives us the option to have is larger data files living on TAC systems that are managed and published via the the Dataverse software that's hosted by the Texas Digital Libraries. And we can see those collections or those files as being stewarded still by the UT libraries. And there's a link here, a bit.ly link to the technical details and the documentation of Jim's work, so that you'll be able to go there once we share the slides. And the work to enable this larger data publication for the TDR was funded by the Planet Texas 2050 research program. So this is an internal grant program at UT. And as part of getting this grant, we're providing a pilot service to other PT 2050 funded projects at UT. So what this will help us to do is test our larger data publication setup and to better understand the use cases before we try and expand this as a broader service to the UT community. So for example, some of the questions we still have are around how big does the data that researchers want to publish get? What's a good way of deciding which data store to use? How well does the data upload and publication process work for users once we actually have those users trying to publish their data? And there are still many policy decisions to make around providing a more fully fledged service. These include deciding the manner in which data stores get set in Dataverse. So which store is the default, when and how do we change to another data store? This is probably going to be at the Dataverse level, but we need to make these kinds of decisions. Accounting for data storage use, how is usage going to be tracked? And whether or not to run certain processes that Dataverse usually does during upload on these larger files and data sets. And probably what's most important is that our pilot also runs in the context of a broader community of stakeholders. So I might be spending most of my time thinking about the local implementation, but the TDR is still a consortial repository, meaning that other Texas Digital Library member institutions may also be interested in implementing their own large or alternative data storage options. And that also means that we can mutually benefit from each other's ideas and experiences in these areas. Additionally, the repository steering committee gets to make some of those higher level policy decisions before being able to add these new data stores can become an option for all TDR members that the Texas Digital Library will actually be able to support. So we'll be reporting back from our pilot project with the Planet Texas 2050 researchers and further work in building out services around this model and this new capability. We'll take more consideration from the UT Austin libraries as well as the Texas Data Repository Steering Committee. I'm happy to discuss some of these other ideas for future work as well. These are much more from the TAC side and our interest in being able to have some more digital preservation workflows on the back end and enabling an easier publication process from users who are already using our systems. Finally, I'd like to thank folks who've been helping us with this project. So that's Jim Myers, as well as Chris Jordan at TAC and Colleen Leon at the UT Austin libraries. All right, thank you very much.
Okay,
I think
so
I'll hand it off to Gustavo to handle the lightning talks.
Yep, so now we'll move to lightning talks. So for this, I'm going to run the slides and then the speakers will speak to that. Basically, before the work conference started, the meeting started on Tuesday night, we sent an email to the people who registered, see if they wanted to contribute a quick lightning talk, 1 slide, 1 minute. We got a couple of people's interests, so it's still 1 slide, but we might give them 2 or 3 minutes because we have a little bit of time for that. So let me get those slides up. Hold on. Okay, everyone should see lightning talks right now.
Yes.
Great. Okay, so our first lightning talk is from Pete Meyer from the Structural Biology Grid Group at the Harvard Medical School. So Pete, you're up.
Okay, so I have not timed this, and also if the traffic outside is too loud, let me know and I will try to shut the door within a minute. So what I'm going to talk about is a project that we collaborated with the Dataverse group on for depositing large primary structural biology data sets into Harvard Dataverse. And the way to do this was to not have the data go through Glassfish. This is sounding like the resounding theme that all these talks have had. The model we went through was we had several coupled components that were used for handling the data movement orchestrated by Dataverse. So a depositor would talk to Dataverse, they would create a data set. The data set, Dataverse would talk to a data capture module, which is our DCM there. The DCM returns Dataverse an upload script, which it hands off to the depositor. The depositor, all they have to do, run a script, tell it the directory their data files are in, go have coffee. While they're having coffee, the script calculates the checksums on the client side, uploads them to the DCM. When the upload is complete, the DCM verifies the checksums and tells Dataverse this data is uploaded. Dataverse moves those files to a offline file system. Well, offline hold embargo, basically meaning this is a black box where your unpublished data will not leak out of. If there is a problem with the upload, the user is notified, you need to rerun the script. There was corruption over transfer, and the uploads are also encrypted because this is SSH, this is rsync over SSH. There is no logins for that. So it's not a security issue. When it's time for the data set gets published, Dataverse communicates with an RSOL, which is a repository storage abstraction layer. I'm not very good at coming up with acronym names. And that transfers the data sets from an offline file system to a file system where they're available to be both downloaded via rsync, replicated to other HPC sites, or accessed directly via HPC sites. And I'm now coming up on 2 minutes of my 1 minute talk, so I should probably stop there. So thank you all.
Okay, thank you, Pete. Our next slide, let me advance, there we go, is Kamil Gurin from Białystok University of Technology in Poland. So Kamil, go ahead. And like I said, do you have a few minutes, 2 to 3 minutes?
Thanks, Gustavo. So we've built probably the biggest Dataverse installation, test installation in the world that have 500,000 of data sets. Imagine how long it took for me to manually create 500,000 data sets via GUI. And thanks, Stefan Kasberger, for your help with your PyDataverse library. I did a performance test and took it on the test installation using Locust.io with 50 concurrent users searching the data with random 1 to 3 seconds frequency with 10,000 unique search queries. And the results are very good with stable average response of about 500 milliseconds and the maximum of 1 second and 700 milliseconds. And I think that results will be much better with new Dataverse 5 with Pajara. I'm pretty sure that it will be much better, yes. And I've got, I think of course that the Dataverse is very reliable, stable, fast, and so on. And it's very easy to build a repository on top of the Dataverse. It's probably it's the best, in my opinion, it's the best software for open repository in the market, yes, in the open source market. And I've got an announcement. A new advanced search portal is coming soon. It will be similar to London Natural History Museum portal, but built on top of the Dataverse and without third-party closed source external collection management like Axiom. It will have 4 different consistent views like list, grid, gallery, and map view. And I hope that the new search portal will be a second game changer just after a new Dataverse 5, yes. And that's all.
Okay, great. Thank you, Camille.
And if you want to test that installation, you can go to that webpage kubek.biaman.pl and take a look at the 500,000 of datasets installation. Okay, thanks.
Excellent, thank you. Okay, so that I think concludes the presentation portion of our breakout group. I think we went a little bit over our original planned time by about 10 minutes, but I also noticed that a lot of questions are being asked and answered in the chat, so I think we're probably okay with that. So for discussion, when Anna and Megan and I talked about it before, we had a few different topics that we thought might be interesting to get people started, but we're also obviously open to general questions and answers, and you guys definitely have a lot of questions as we're seeing from the chat. So a couple of topics. The first is, you've heard a lot of these different technical efforts, so any feedback you guys have that you want to tell us about or ask about would be much warranted here. The second will be if we potential policy and service implications for managing repositories. And then the third, we are a community and we want to work together on these things. So what can we do to continue and increase coordination and building on these efforts? And then, like I said, lastly, we have general Q&A. So I'm sharing the slide, so I can't see the list of participants as easily, but if someone wants to ask a question, you can use the raise hand feature. We want to try just unmuting and talking. That could work as well. But if too many people talk at the same time, we'll go with raised hands and call on people.
I think there may also be a few questions that got asked in the chat which haven't been answered.
Right.
So if you do have a question like that and you prefer not to say it aloud, can you please recopy it just so we can make sure and we catch it now?
And for the record, I've been trying to save all the questions that people have been asking in the chat. So just for posterity, and so that we can answer whatever we cannot answer during the session.
Excellent.
Yeah, and Dwayne and Mike and I have been putting questions in the notes doc, and folks have been answering in there, but there are some that are unanswered.
So
Right.
Denny,
and even the ones that have been answered,
have a couple of those.
Sure. So a question from Obi. Have there been any tests of these remote storage systems against the external tools mentioned in the earlier session? That's probably to John and perhaps others.
Right.
So do we get the external tools experience with all these with these remote options for storage?
So
in our case right now, the answer is no for the TRSA. We have not integrated those tools. You have to actually go through the enclave to access the data. So I think that would be really good, but our use case was sensitive data, so we didn't do that.
John,
Cool.
there's also
Thanks, John.
there's also a question. Do you push the metadata and links to a data set that has already been created in Dataverse, or does TRSA create a data set? Would a data tag be assigned as part of the push to Dataverse? Would it be done in Dataverse?
So all good questions. TRSA can create an empty data set and then you put it in there, or you can point it to an existing data set. Everything can happen within TRSA. Data tags were not developed or not developed yet. So we have planned to be able to do that. Any metadata that can be, any metadata that can be in the JSON package, then you can create within TRSA and push that package. But once we get, operational data tags, we intend on the data producer putting that tag on, because it's the responsibility of the producer, the data provider, to do those tags in our model anyhow.
Thank you.
Looks like someone has their hand up, actually.
Hi,
Laura,
yes, I'm part of the Texas Data Repository. One of the questions we've been kind of circling around is funding for some of this. And if, like, in a scenario where researchers are choosing these different buckets, as you might call them, how to manage some of the, if that's part of their grant, how to manage kind of paying for the storage separately. I was just curious if anyone had policies or information on that.
I could talk about the Scholars Portal context, where we actually just want to make sure that there aren't any sort of barriers for researchers to be able to deposit, so there wouldn't be, any cost associated with them using the service. And so the way we've been working is we have agreements with the 4 library consortia across Canada. So now we have 55 institutions participating. The institution pays sort of a fee for like a base allocation of storage. And so far that hasn't really been a problem. No one's really come close to that, because Dataverse right now we can only accommodate, 2.5 gigabytes per file. So the file sizes for the data sets in these institutional Dataverses has not been very big. But as we can envision, we start using things like large file transfer tools and things like that, that's going to start to really balloon, and we'll need to have some better policies in place for how we'll have sort of like a charge for when institutions go over that limit, for example. In some cases, the library consortia is going to look after it together. In other cases, it's individual institutions that are participating. So it has a lot of policy implications. So there's going to be a national governance framework and model we're putting in place to look at that, and also looking at how we can perhaps subsidize the cost to institutions by getting national funding as well to help pay for storage. So those questions are all really still we're trying to answer those kinds of things, but it's really important if we start thinking about, different kinds of storage, using large tools to get large data in. We're going to have good answers soon for that. And it's not great when a researcher asks me, like, what's going to happen, and we don't have a good answer for that for the future. So we'll have to figure that out. Does anyone else have any thoughts about those kinds of questions around policy and costs?
Yeah, so that's exactly what we're thinking about here. And Laura's question is kind of a conversation back and forth within the TDR. And so for our pilot project, we're already starting to think about that. And there we're thinking specifically, since I'm on the TAC side, like, how does TAC manage storage? And we operate on kind of a cost recovery fashion. So there would need to be payment for a lot of data storage, and that's usually on a yearly basis. But the question is, do we charge the libraries? Are we charging individual researchers? How do we track how much space an individual researcher is using if it's not through tax accounting system, if it's just through Dataverse? So there are a lot of questions around that as well. And for us, we'll be asking and trying to answer some of those questions as we report back on the pilot and how we think it could possibly work for us, and try to generalize from there a little bit too.
It might be nice to maybe have an idea of how different players are dealing with this, so we can look to other models as well. I think that would be really helpful to kind of think about the management piece of that. Sometimes we get individual researchers asking. There's one who recently said he's aiming to have 100 terabytes of data over 20 years and wants to know if we can accommodate Well, we haven't planned 20 years into the future. That seems astronomical, but it'd be great to hear how other people are doing this kind of long-term planning as well.
Yeah, for that, the answer seems like yes. We usually deal with researchers who don't plan that far in advance. So it's shocking and excellent that they are.
Thank you all. That's really helpful. I appreciate it. Thank you.
Okay, so a couple of recent questions that have come in. There's one from Olaf, excuse me, which I think might already have been answered by John, but let me just add a couple of point or so. It's just the question says, how should one look at external tools? Maybe one can envision Dataverse as an external tool of another system. This challenges the way one is doing access control. So yes, if you're referring to external tools in the case of the remotely managed storage, then I think John's answer is fulfills that. But I just, when you talk about Dataverse being an external tool to another system, I agree completely with that. I think, you know, when we talk about external tools, obviously we're talking about external tools to Dataverse because we're looking at the Dataverse side. But if you look at, for example, our collaboration with the OSF, Open Science Foundation framework, excuse me, there we are effectively an external tool for them. You go to OSF and we are one of the areas where they interact with our APIs to store to us. And so yes, external is relative to your starting position. And then there's a question a little bit later from Pete Meyer from Megan, actually. So Megan, could you say a little about how you're currently recording the Dataverse storage ID model with Globus and if it supports direct compute access?
Reconciling, not recording.
Or reconciling, excuse me.
So if with Globus, the Globus piece is really just the transfer mechanism. So you're actually just transferring from some source endpoint, whether that's your personal computer or a server or something like that. You're using Globus to transfer it to essentially an Amazon S3 storage. We just happen to have our OLRC underneath it. It's an emulation of Amazon S3. So it's the same sort of setup as, say, Harvard's Dataverse with Amazon S3 and that way. So it's just being that like broker that's bringing the data from one place to another. And so for that period of time, a user would have edit access to be able to transfer the files to that particular directory that's created for that data set. And then that access is closed once the transfer is finished. So and then if you need to add more, it opens it again. And then for users who want to download the data from that directory, they are also given edit access temporarily, or read access, sorry, temporarily to then be able to download the files. So the question about direct compute access, we haven't looked into this at all, but I think that would be possible since essentially we're using our sort of storage, our Dataverse storage as an endpoint. It's a managed endpoint. So you could potentially be able to do that if you had the proper permissions, but we'd have to look into that more closely. We haven't looked into it yet. But I can look into that and maybe I can add some thoughts in the notes document later after I talk to the team at Scholars World. Does that answer your question, I hope?
It does answer my question, yes.
Okay, good.
Just from, at least based on my experience, adding the direct compute use case increases the complexity quite a bit.
Yeah.
So if your users do not require that, then I would say leave that as it is.
Okay. It would be interesting to hear if that's something that would be useful to the community. That's one of our questions here is like, when we're thinking about developing these tools, we want to be able to coordinate and get feedback as we're developing them too, because we don't want to kind of create this isolated use case. It'd be great to have kind of other users try it out even, get some more feedback about the functionality is there or that kind of thing. And that might be a really important feature for some people, but we haven't really thought about it yet for us. So I'd be curious to hear more about that.
So going back through the chat, just trying to find other questions that may not have been answered. There's one from Sherry Lake that says, for TRSA, do individual files need their own DOIs? And I think it's directed at John, but I think I can answer that. But basically, I mean, the interaction for DOIs with DataSite and other PID providers is really all just about the metadata. So I don't see any reason why files that are stored in TRSA would work any differently than any other files. You'd still get the DOI, it would point to the landing page on Dataverse, and then Dataverse would still point to the remote remotely managed storage as needed. Okay. Are there other questions that we missed from the chat? If you want to type them in again, if we missed them.
Gustavo, there is a question on the notes doc to you saying, how should one look at external tools? Maybe one could envision Dataverse as an external tool of another system.
Yep.
This challenge.
I answered that one. You may have missed it, but that was from Olaf.
Oh,
And
sorry. I believe I put your answer to somewhere else. I will
no
move
worries.
it.
I'd be just curious to hear if anyone else has any feedback about what they heard today about these efforts. How would you like to learn more about them? How do you think we should be coordinating these efforts? Yeah, if you have any thoughts about that, it'd be really great to hear.
And one thing I'll say to that specifically is, we clearly went very fast through lots of information, and 10 minutes for each of these topics is not nearly enough time. So we often have dedicated community meetings, community calls where, for example, that we could have one about the Globus demo, which we've done with you guys directly, but involving the whole community, so expand and have, a more 30-minute demo / conversation about it during one of our calls or about any of these topics. So yeah, as you're interested and, we want to collaborate, and collaborate doesn't mean you have to necessarily do any of the coding itself. It just means you're involved in helping develop the use cases and figuring out what the solution should provide so that we or whoever's working on it can provide the best possible solution for the entire community. And, we can keep talking about that here now and then at future community calls and things like that.
Those are bi-monthly calls?
Yes, once every other week.
With different times for the folks around the world? Correct.
It's once every other week, and there are 2 calls. One that is, and I don't remember the UTC time, but is 10 p.m. I think East Coast time, U.S. East Coast time, on Monday night. So Tuesday morning in Europe and Tuesday later in in Australia and Asia. And then the other one is 11 a.m. now. Sorry, it keeps switching with the daylight standard time and daylight and standard time. So it's 11 a.m. now on East Coast time.
More information at dataverse.org.
Yes.
I see another hand up from Brian Westra. Would you like to ask your question, Brian?
Yeah, I thought all the presentations, the whole conference was great. The ones in this session were really interesting to me because I see we're not a Dataverse user yet, but I see a lot of application to things that I'm bumping into because we have a lot of biomedical data and we really don't have a good workflow for managing that internally, as well as providing, a fair approach to provide a record in the repository and a process besides a manual process where they do a data use agreement. So I'm really intrigued by impact and trusted remote, as well as big data, the Globus integration. Megan, I was just kind of curious if you foresee training or a user interface issue, or do you think most people that have big data are pretty comfortable with, FTP kind of interfaces and so on?
It's a really good question because we have talked about that a little bit with the Globus transfer interface. Like if you have a little bit of time, it's quite easy to use, but if you aren't really familiar with these kinds of tools and you're kind of just presented with it, would you be able to figure it out? So we've been thinking about ways that we might be able to mitigate that sort of like initial, this is a huge tool, what do we do? With documentation or training videos or things like that. We do think the people who would be using it probably would have, at least some technical background to be able to use it. So there is that piece. So it's a tough call to have the right balance there. But we also think it might be worthwhile to look into developing our own UI using the Globus API so that it could be maybe a better kind of transition from Dataverse to using that new tool. So it's not such a shock to see that separate application. So lots to be figured out there. And I just want to bring up the getting some user testing and people trying like various iterations would be really great to make sure it's meeting the needs of the community for sure.
Broader question, do most of these that are kind of proof of concept, is there like so there's the roadmap for Dataverse projects, but is there kind of a roadmap for these things as well? So, you know, if I'm putting in a request or a recommendation that we go with this, I can say, well, Globus Dataverse integration would be really useful. And I can also say, I'm pretty sure it's going to be ready for prime time by such and such a date, or, you know what I'm getting at?
Yeah, Gustavo, do you have a comment about that? About the like community?
I think it's a great
efforts?
question. I actually might ping Danny on it because he does the management of Dataverse on the core team. I think we have had talks about it, and the challenge is obviously, you know, what we can manage and what's being worked on external. So how do we deal with creating a roadmap for the community when, again, we don't actually manage that directly? So Danny, would you mind?
Sure. Yeah. I mean, you articulated it well. I think one of the really cool things that the GDCC could do is to, and one of the reasons it does exist is to coordinate these efforts across the community. So in the future, that could be a product of the GDCC. I don't want to put either John or Merce on the spot, but I guess by mentioning their names, I just did. But it would be really cool to better coordinate all this really cool work going on in the community that's not necessarily happening with the core Dataverse code.
And I know it's a process, so I'm not trying to put anybody's feet to the fire or anything like that. I'm just, the presentations I saw made me kind of wonder, okay, this looks cool. I'm not quite sure when it would go into production. You know, so I don't know if I want to bring it up because it might be quite a long time before it's ready to go. Hope that makes sense.
In the flexible metadata session, there was a recommendation of creating a work group. So maybe a work group for storage is also required here.
Yeah, and to follow up on Dennis, I think it is a good idea. John and I can discuss it about how the best way to sit on that, and maybe through working groups, but also have a transparency in some public public page that where it shows that this information. The question is always keeping everything up to date, right, and collecting. So it has to be a collaborative effort so that it's up to date.
Just slightly stating the obvious on that, right, the decision of when you can complete things by is in the, right, that's the decision of the people who have the money to do the work. And the one place where that sort of truism breaks down is if the plan is to then merge it into the code base, now you've got a decision between multiple organizations. And I think if, you know, GDCC could potentially have a role in sort of collecting these things so that they're available, as well as trying to get that last mile, right? If this is going to be done by X, can we help make sure it's going to get scheduled into a merge, you know, on some other time scale, so that everybody can kind of have a total time scale for it.
Yeah, that's been quite an interesting
That's the one thing we can coordinate from the core team. Is just, you know, we obviously are very interested in all these things and want to get them in, and so we do, as these efforts are being worked on, we do try to prioritize coordinating with the groups that are working on them and prioritizing pull requests as they come in to, you know, try to get them merged ASAP, and get these functionality out there.
Yeah, I was just going to say from our side, from our experience, that's been, I think, a very good experience, because I very much live in my little tech world, and then, you know, we communicate with TDR. So we had the development instance of TDR with some of the code that Jim wrote, but we can't update or upgrade the live instance really, because we want to stay kind of in touch with what's going on the main branch. So we had to wait for everything to go into the main branch for the 4.2 release in order to be able to upgrade the actual repository. But that's been a very smooth process, I think. And yeah, just kudos on being able to do that with so many so many different groups involved.
Just a quick comment or question that a while back, a Google group was set up called Dataverse Big Data. And I don't know, I'm not sure if I heard it during this session. I don't know if that's still a place that we want to try to use, that we all subscribe to that. It's called Big Data. There's no sensitive data in the name, but I put a link in the chat if people want to check it out. It has not been very high traffic. But I feel like sometimes we want to do these working groups, but we don't always get it much momentum, at least on a Google group.
Yeah, I think it's a good idea. I mean, if we don't use that particular Google group and we just try to come up with a broader name, I think that might be fine. But I think that should definitely be probably one of the outcomes of making the GDCC working group for this is, have a good mailing list or, group to use to coordinate. Right, exactly. I think Jonas should in fact just come in and said something very similar. If this becomes a DTC supported group, maybe that could change. So.
Yep.
I will just say briefly that it's so cool to see all the work here, because I remember the first Dataverse community meeting that I ever attended. John Crabtree says, we all have to work together to figure out the remote storage thing, because if we don't, we're dead. So it's really great to see all the progress here, and I'm really excited to get a lot of this stuff into the project.
So we have about 4 minutes left. So if we have any last questions, we can get them asked, hopefully, and answered. But before we go to that, since I see people are slowly starting to drop out of the Zoom meeting, I did want to make sure to remind everyone that there is one more session left. It starts at 1:15. It's the closing session and social event. And I encourage everyone to come, because I think we'll hear good summaries of all the different meetings that we've had. And also, it has been one of the traditions of this meeting, as a lot of conferences, to have a group photo. And I know we are planning, it will be very different than the standard group photo, but we do plan on trying to coordinate a series of group photos of all these different Zooms, and then, merging them together to have a group photo of this year's conference. So please make sure you come and attend at 1:15, the final session. It's BYO sandwich, though. Bring your own sandwich.
Indeed. Hey, Megan, you may have already answered that question, but I'm not seeing it in the notes. So is there a plan for some kind of a pull request of the Globus integration code that can be like merged into the main Dataverse project? I think
right now it's just a proof of concept. So it's a separate branch that we have for our GitHub. I can add the GitHub link if people want to check it out. But we'd want to work with IQSS and others to have a big discussion about what we want to do to integrate that into the core code and move from there.
If we can help with that, we will, because it sounds very promising.
Oh, awesome, thanks. Just wanted to say thanks to all the presenters today, and thanks for everyone for your questions and great discussion. Really exciting to see so much interest in this topic. And thanks for having me too. That was great.
Thank you.
A special thanks to both Pete Meyer and Camille Gurin, who I recruited, I believe, within the past 48 hours to work out their slide and give their talk. And I think they were great additions to our planned presentations.
Thanks for inviting me.
Thank you.
Thanks, everyone.
Thank you, everyone.
A little over 15 minutes.